we've already discussed trigonometric derivatives for the sine function and the cosine function. And remember that sine of x derives to cosine of x, and cosine of x derives to negative sine of x. Now, to find the derivatives for the other four basic trigonometric functions, what we find is that we can use what we know specifically with the quotient rule to derive all four of these. So tangent of x derives to secant squared, cotangent of x derives to cosecant squared, secant derives to secant of x tangent of x, and cosecant of x derives to negative cosecant x times cotangent x. So I'm going to do the case where we derive the tangent to prove this, but know that they're all really just a function of the quotient rule. So to prove this, what we're going to do is instead we're going to rewrite tangent of x as sine of x divided by cosine of x, right? That's its definition. So then we're going to use the quotient rule to say low d high, so low d high minus high d low over low, low, so that's where we get the squared from. So the derivative of sine is cosine, remember that's from here. The derivative of cosine is negative sine, so that goes here. So now I have cosine cosine minus sine times minus sine. And remember that convention just says, instead of writing this, we can shorthand it as cosine squared x, like this. So then we end up with cosine squared of x plus sine squared x on top. Now, there's the Pythagorean identity, probably one of the most well-known trigonometric identities, that says sine squared plus cosine squared is always equal to 1. So by doing that, knowing the fact that secant is 1 over cosine, then secant squared is 1 over cosine squared, which gets us our result of secant squared x. And, for fun, maybe not for fun, maybe for good practice, it would be helpful for you to derive all the rest of these just to see and understand the process, understand where these derivatives come from.